Pod and all right, so now we're going to be looking at some word problems that match the rational functions we've been doing, where the degree and the numerator and denominator are the same. So the cost of cleaning X% of an oil spill that is washed ashore can be modeled by C equals 20X over 101 minus X, where C is the cost in thousands of dollars. So when we solve for C, like say we get 5, right? So it's now $5, it's $5,000. Use a graph to approximate the cost of 100% of the oil spill. What happens to the cost as the percent of cleanup increases? All right, so X here is a percent we're cleaning up, and C is how much that's going to cost us to clean it up. All right, so let's find our vertical and horizontal asymptotes, and then we'll fill in some values. We'll put a scale on this graph and put in some values. Notice I don't have a coordinate plane. I have actually just one quadrant of a coordinate plane because negative money won't make sense here and negative percent doesn't make any sense. All right, so just positive values. All right, so how about the vertical asymptote? Blue 1. Remember what you do? What do we do to find a vertical asymptote? What do we do with our denominator? Help him out. Set it equal to 0. All right, so now if I'm solving that, what should I do first? Do we get X by itself?
X plus on both sides.
Okay, yeah, that works. So 100. So if you add X to both sides, 101 equals X, and that's our vertical asymptote, right? So X equals 101 is our vertical asymptote. I think I'll just write your step and then write it the other direction. So X equals 101. All right, so we'll graph the. Actually, we can't graph it until we put some numbers up here. Maybe we'll find our horizontal and then we'll put some numbers up there. The horizontal asymptote, purple 4. Yep. So our horizontal asymptote y equals 20 over negative 1, which is y equals negative 20. All right. So probably maybe I'll make negative 20 our lowest value here. All right, so let's put some values on this. All right, so let's see, maybe I go up by 20s. Let's see, if this is 0, 10, 20, or 10s. 10, 20, 30, 40, 50, 60, 70, 80, I don't have enough. We'll go up by 20s. So maybe I'll put 0 here. And then this would be 20%, 40%. Oops, why did I do that? That doesn't fit. Oh, I'm still going up by 10s. Crazy me. Each line's going to be 20. Let's try that again. 20%, 40%, 60%, 80%, 100%. All right, that'll be fine. All right, so except, oh, I have one problem. Anyone see the one problem? What's that?
You don't feel it all.
No. What's our independent variable? What depends on the other? So let's do that. Which is the cost is the dependent, right? So cost belongs on the. So I'm thinking about the percent, but I'm not putting it in the right spot. Sorry, people watching. You're going to have to just see my boo-boo. So before you put the numbers and have to erase it like I just did, probably should think about which is independent, which is dependent. It's not the first time where I start putting the numbers in, I'm like, but probably should have thought which is independent. Independent is the percent, dependent is the cost. All right, so let's try that again. They're going to go down here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Almost could fit it in going by 10%. Maybe if we put negative, so we have negative 101. Yeah, we could go by 10% on the bottom here. So 0, because I'm thinking about the negative 20, and that's our horizontal asymptote. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right. So now I'm going to stop messing up. All right, everyone clear why the percent is along the bottom there? Okay. It's our independent variable. All right, so we decide how much we want to clean up, right? You can clean up nothing, right? But once you decide how much you clean up, that will determine how much it costs. All right, so we put in these numbers. Let's wait to put in the y values to see, so we see what kind of points we get. All right, so but we have that in. And we could graph our vertical asymptote, which is way over here. It's just past the 100 mark. All right, so we'll just put it right out there. All right, so there it is. By the way, we're not graphing anything on the other side because I don't know how to do 102% or 110% of a job. All right, you do 100%, you've done all the job. Right, so all of our values are going to be on this side because those are the only ones that make any sense. So only makes sense to have them less than 100, so 100% and less, and to have them be positive costs. All right, so let's plug in some values. We'll choose some percents. All right, so we could choose 0, right? 0 would work. Let's say we don't clean up any of it. All right, if we don't clean up any of it, we have 20 times 0 over 101 minus 0. So 20 over 0 is 0, and so 0 over 101 is 0. All right, so obviously it won't cost us anything if we don't clean anything up. But then we have this oily, messy beach that is destroying that whole environment. All right, so let's say we clean up 10%. You know, we're going to just kind of give it as my grandfather would say, a lick and a promise, right? We're going to do a very lousy job and clean up only 10%. All right, so 20 times 10 over 101 minus 10. That's going to be 200 divided by, so that would be 91. Somebody put that into a calculator for me and get that to me as a decimal number, because this is money. All right, so someone can do that one. And then let's do a little bit more. Let's do 20%. Actually, let's do 25%. Let's stick it to 20%. 20%'s on there. I was thinking, well, maybe we'll do a quarter of the job. Yeah, we'll stick to 20%. So we have 200 times 20 divided by 101 minus 20. That's going to be 400 divided by 81. All right, so somebody takes care of dividing that for me. And then let's do 50% of the job. All right, we'll do half a job. So 20 times 50 over 101 minus 50. That's going to be 1,000 divided by 51. All right, somebody else is going to take care of that for me. And then let's do 70% of the job, almost all of the job. That would give us 20 times 70 over 101 minus 70, which is 1400 over 31. And someone does that one. And let's do 100% of the job. All right, so if we do 100%, that's going to be 20 times 100. And in the denominator, it's going to be 101 minus 100. You can see that, hopefully. I don't know what happened to my 100 there. But that's just going to be 20 times 100 would be 2,000. And then divided by 1. So that's 2,000. All right, so someone tell me my other numbers. 200 divided by 91. Quickly. 2.198. And then 400 divided by 81, sorry. 400 divided by 81.
4.938.
4.938. Maybe I'll write them over here for me. So it's going to just be over here. And then 1,000 divided by 51. Yeah.
19.608.
19.608. And then 1,400 divided by 31.
45.161.
Okay, 45.161. All right, so now we got to figure out the values here. All right, so the top one is 2,000. So 1, 2, 3, I think we got 10 there. So if we go up by 200, that should work. Yeah. So we'll go up by 200. All right, and now I'm going to write in red or something so you can see the numbers. All right, so 2,000 would be up here. And then I'm going to write every other one. This one would be 1,600, right, because each one of these spaces is 200. And then this one here would be 1,200. And then this one here would be 800. And then the next one would be 400. And then this would be 0. All right? So now, sorry about the numbers crowding our graph here. Let's graph our values. And then we have our vertical asymptote, which is down here. So I didn't give a space to it because, well, 2,000 was a lot to get in there. But it's down here. Notice none of our values are this low, right? So we're not going to have to worry about anything below our our horizontal asymptote. So this is y equals -20, our horizontal asymptote. And this is x equals 101, the vertical asymptote. And notice none of our values are near that. All right, so let me graph it in different colors so it's not. There it is, purple. We'll graph in purple. All right, so we have 0, 0. We didn't clean anything up, and it didn't cost us anything. There we go. Just left a mess. All right, so then if we cleaned up 10%, just do a little bit, hardly anything at all. Well, I got a lot of numbers to fit in here. So each one of these spaces is 200. So this should be about 1/100th. So I'll make that as low as I can, and you can still see the dot. And it's not quite 0. All right, then the next one is 4. So it's just a tiny bit more, or actually almost 5. So also really, really low down there. And then at 50, so I jumped over here to 50 because these numbers are really small, we got 19. Right, so that should be 1/10 of the way because each one of these lines is 200. So maybe there, right? So we're still really small. Then we got to 70, and finally we were a little bit higher, 45. So if this is 200, that's 100. So approximately here would be 45. Then I get up to 100, and it's going to be 2,000, way up here. All right, so let's take a look at our graph here. It's a pretty steep curve there at the end. Let's fill in the blanks here, and let's actually put in the actual cost rather than how many thousands of dollars. So let's fill up 50%. Cleaning 50%. So we had 45.161. That's thousands, right? So that's $45,161. That's how much it costed to clean up 50%. 2,000 thousands is actually $2 million. So to go from 50% to 100% cost us quite a bit more. 45,000 for the first 50%, 2 million to get the second 50% done. Right? Quite a dramatic increase. So the costs increase dramatically as the percent cleaned approaches 100%. Why do you think that cost increases so dramatically towards the end there? Cleaning up an oil spill here.
Because you gotta focus on cleaning up animals and getting every little bit. Plus, you have to pay all the workers who did things.
Yeah. Yeah, so in the beginning, if I did like 10%, I could clean up a couple of rocks. Maybe I find a seal and clean him up too, right? But at 50%, I'm probably cleaning up all the rocks and all the animals, but my sand's a mess right? And it's still going to leach out into the ocean. At 100%, I've cleaned up every little grain of sand and every little bit. How many times when there's an oil spill do you think they actually clean up 100% of the oil spill? Probably never. So anytime there is any kind of environmental disaster, the remains are left because of how expensive it is to clean up 100%. Right? So that's why they need to make sure they prevent rather than try and clean it up because, well, they're not. Right? So here is a practical use for rational functions, looking at the cost it takes to clean up something. Right? So moral of the story, don't make a mess. Any questions on this one? We're going to do one more real world one. And this one, instead of being cost of cleaning something up, it's going to be cost of making something. Right? So it's manufacturing costs. So the average cost, C, of producing X wheelchairs can be modeled by C equals 300,000 plus 2X over X. So we saw an equation like this when we were solving rational equations. Think back to the cost one. What do you think the 300,000 represents? What kind of cost is that? Starting cost, fixed cost, exactly. So these are our starting and fixed cost. Right? No matter what, you have to have the machinery, right, at the factory to make the wheelchairs, make whatever it is you want to make. And then what's the 2X represent?
Slope.
In the context of the problem. What's that? I can't hear you, I'm sorry. Well, okay, X is how many we can make. What's the 2X? Kind of put the ideas together, but in context.
The price to make one?
The cost to make one, yes, the cost. So, because this is the cost. So, cost per wheelchair. All right, so you have some costs that are, the metal. Seems pretty cheap, but cost per wheelchair. These, I guess, aren't your fancy wheelchairs. So you have some costs, the metal that goes into it, the little seat and whatever, the back thing. And then you have the fixed costs, the factory and the machinery to make it that you're going to have to pay no matter how many wheelchairs you make. All right, so let's find the vertical and horizontal asymptotes, and then we're going to, we'll answer the question, and then we'll graph on the next page. So what's the vertical asymptote? Orange 5. Orange 4.
Vertical asymptote is 1 or
0. And X equals 0. So X equals 0 is the vertical asymptote. Actually, let me write vertical asymptote first. What do you think that means for the company if there's a vertical asymptote at 0? I'll just let you volunteer. What do you think that means for the company?
It started with nothing. Or
So X is X wheelchairs. So X refers to the wheelchairs. What do you think the vertical asymptote of 0 means? What's that?
They can't produce less than 0 wheelchairs.
Yeah, they can't produce 0, right? Or they have nothing to divide. They just spend a lot of money and they couldn't possibly recover their costs, right? So you can't make 0 wheelchairs. You're not in business if you're not making anything. So this is our vertical asymptote. Can't make 0 wheelchairs. And then how about, what's the horizontal asymptote? Purple 2
Is it 2?
is correct. Y equals 2 is the horizontal asymptote. All right, and what do you think that means for the company? We kind of talked about it. It's a hint on the board. What's the 2 mean?
Cost.
Cost per wheelchair, right? So horizontal asymptote. All right, so our variable cost $2 per wheelchair. All right, so we'll graph that on the next page. We've got 0 and 2. And we're interested in 1,000 wheelchairs, or was it, I think it was 10,000. 10,000 wheelchairs. So we better go up by a number that makes sense for 10,000. Which is the independent variable? Wheelchairs. And therefore, of course, our dependent is the cost. The more wheelchairs we make, the more it's going to cost. Right? But for how long? How much more does it cost? All right, so we want 10,000. I guess we'll go up by thousands. That'll work. All right, so each one of these, so this is 1,000. And actually, I'm going to number every other, otherwise it's going to be kind of crowded up here. So this one is 2,000. This is 4,000. This is 6,000. 8,000. And 10,000. And then, so that's how many wheelchairs we're making. And then we'll see what the costs are, and then we'll be able to figure out what to number those by. All right, so we've got our vertical asymptote at x equals 0. So right here, so we obviously can't make negative wheelchairs, right? So nothing's going to be on the other side. Where's my vertical asymptote? There we go. All right, so now we'll draw in the horizontal asymptote. That was y equals 2. All right, so I don't know what numbers to go up by, so we'll hold off on figuring out graphing that one. All right, so let's find some values here for our graph. All right, so we can't plug in 2. Let's plug in numbers, I guess, that kind of make sense for our, we can't plug in 0, that makes sense for our graph. Maybe we could do, so this one would be 1,000. Maybe we can make 500. It's kind of a small number. All right, so if we make 500 wheelchairs. All right, so we may not graph this one, but let's see the cost of making one wheelchair. If we were a horrible company, we made one wheelchair. So it would be 300,000 plus 2 times 1 divided by 1. So this would be a very, very expensive 300,000 and $2 wheelchair if we only make one. But let's make more than that, and let's see what happens to our costs per wheelchair. So we'll make now 100. Or actually, let's make 500. I can graph that pretty easy. 500. So now we have 300,000 plus 2 times 500 divided by 500. All right, so that's going to be, this will be 1,000 here, so it would be 301,000 divided by 500. So somebody divide 301,000 by 500. Give it to me as a decimal number for cost. So 301,000 divided by 500. $602. All right, so that's gone much, much less. All right, so let's do 1,000. So then we have 300,000 plus 2 times 1,000 divided by 1,000. So that's going to be 302,000. If I divide by 1,000, that's just going to be $302. Well, if we leave off the $302,002 wheelchair, we can go up by much smaller numbers. Let's do 5,000. All right, so then we have 300,000 plus 2 times 500, or 5,000, divided by 5,000. All right, so that's going to be 310,000 divided by 5,000. Can you divide 310,000 by 5,000?
62.
$62. Let's do 10,000. Or excuse me, 10,000. That's going to be the last number we put on here. So if we do 10,000, that would be 300,000 plus 2 times 10,000 divided by 10,000. So that's going to be 320,000 divided by 10,000. That's going to be $32. Right? We can take larger numbers. Now we won't graph it, but if we plugged in 100,000, how much do you think it would cost if I put in 100,000? Looking at the sequence of numbers. So instead of 10,000, there's 100,000. What's that?
320.
Go in the wrong direction.
Maybe like $2. It's gonna be like $3.20.
$3.20. So if we made 100,000 wheelchairs, it would cost us $3.20.
Oh.
All right, so 3.2, $3.20. So let's graph these. Let's put numbers up. Let's go up by, so we won't be graphing the 300,000 one. Let's go up by 50 maybe. No. That'd get me to 500. Let's go up by, I guess, 100. All right, so that'd be 100, 200, 300. This would be 400. I can't get the other numbers in. And then 500, 600. Don't really need any of the other numbers. 700, 800, 900, 1,000. All right, so if we're going to make just 500 wheelchairs, we'll be right here. It's going to cost us over $600. Oops, over $600 per wheelchair. Just a little bit more than 600. All right, and then if we make 1,000, that price is dropped a little bit, and so now it's a little over $300. And then if we make 5,000, we're over here, they're going to be $62, so a little bit more, about 2/3 of the way. And then if we drop that down to, we make 10,000, we're all the way down here to $32. And of course, if we made $100,000, then we'd be down to quite a lot less. This is obviously going to go like this. Oops. Oops, I missed my point. And of course, it's going to keep on decreasing. So I think it's pretty clear that as we make more, the cost goes down. Right? You're dividing those fixed costs between more and more wheelchairs. So if the company was smart, should they make like 100,000 wheelchairs?
No. Yeah.
Why not, Devin? Some people say yes, some people say no. Why not?
Basic supply and demand.
Yeah. If you don't have 100,000 people that want wheelchairs and buy these wheelchairs, you just spent money to make them and they're just sitting there. So you also have to be able to sell them. So there's some other mathematics that we would do to figure out what's the optimal supply and demand. Right? What would be the optimal amount so that we'd actually sell the wheelchairs. All right? But the cost decreases as the number increases. So it's not really practical to make 100,000 wheelchairs. I don't think 100,000 people need a wheelchair. So I'm going to end this tape.